We're doing another words over episodes here for STEM revision, and it's going to be a further Pure 1 episode again about numerical methods for solving polynomials with special guest Dilraj.
Hello, what's happening?
Good to have you on the show, man.
Oh, sorry.
Yeah. And so
it's great to be here.
So you're going to be doing linear interpolation.
Okay.
I'm going to be doing some other stuff.
Okay.
And it's going to be sitting here. Nice.
Is that okay? We are doing the linear interpolation method, so I might as well just linear interpolation method. Yeah, sounds good so far. Right, now our question is x cubed minus 3x plus 7 equals 0. Now the question tells us that x has a root between minus 2.2 and minus 2.6. Yeah? Minus 2.2 and minus 2.6. So far so good. Now, the method we could use, there's a great formula to do this method, right? And that formula is a times f of b. Yep. Minus b
Times f of a.
Times f of a. And that, all of that over f of b minus f of a.
Yep.
Sounds good? Everyone with me so far? Okay. So that is the formula we're going to be using.
Right.
Now, we know that a is equal to minus 2.2, as it says here, because it's the root between minus 2.2 and minus 2.6. So far so good. And b is equal to minus 2.6. Yeah? You with me? Now, we need to know what the f of b is, and we need to know what the f of a is. So Sam, can you tell me what is the f of b?
Right, so if you substitute in minus 2.2 into the position of x, your answer isn't going to be 0 because the answer is not 0.
It's going to be 2.952.
Oh, that's for this one here.
I do apologise. 2.952. It was an easy mistake to make.
And f of b is minus 2.776.
Minus 2.776. Now, I want you guys to understand how he did this. He substituted this number into the equation, right, in the form of x, and instead of getting 0, he got 2.952. With this number, he got minus 2.776.
So there's a change in sign between the two numbers.
There's a change in sign. This one is a positive number, and this one is a negative number.
It's definitely between those two roots. Okay.
Yeah.
What do you know?
Sounds good. All right. So now it's quite simple from here. It's really a matter of copying and pasting. Really, you put these numbers into the formula we have here. So we have minus 2.2. So now that we've got our formula here, we have a one-way ticket, right, to exam success. Right here. We've got all sorted. So Sam, because I don't want to waste your time here.
Oh yeah, with the calculations.
Yeah, obviously this would come as a calculator question, obviously. So you would have your calculator close at hand. So all of this, if you type this all into your calculator exactly how you see it, it all equals, Sam, do the honours.
2.4061452551. So minus 2.41.
Wait, 2.406114.
I just go for minus 2.406.
Alright, which is minus 2.406.
And of course you can keep doing that if you wanted to with that new number, and you can keep linearly interpolating it and get a more accurate answer.
Even more accurate answers.
But that's fine.
But this is fine for now. So we have our answer, minus 2.406. Thank you very much, ladies and gents. I hope you enjoyed, because I know I enjoyed. And if I enjoyed, I know you enjoyed.
We're doing another method here for numerical methods, and it's called Bisection this time. It's more basic, I think, and it's the first one you should learn. We're going to see if we can get an answer close to your answers here. So what you start with doing is the formula is f of a plus b over 2. And so that's bisecting it to split into 2. And so we substitute in minus 2.2 and minus 2.6, and last time we got a negative and a positive, so we know it's between these two roots again. But this time we know what the f of a is and f of b is, 2.952 there and minus 2.77 there, but we're going to bisect it. So a plus b over 2 is going to be minus 2.4, and what is f of minus 2.4, Dilraj?
F of minus 2.4, Sam, is 0.376.
Nice. 0.376 is quite close because it's to one decimal place here of the answer, and it's positive, so we can, because it's positive, we can replace it with the positive answer from before here, and so we'll now bisect between minus 2.4 and minus 2.6, and in between that is going to be well, right in the middle will be minus 2.5. And what's f of minus 2.5?
Sam, f of minus 2.5, you'll get minus 1.125.
And that is higher, a bigger number than, well, not bigger, but closer, not as far, far away from 0 than this number here. And so we'll try and bisect between these two numbers here because it's negative. So between minus 2.5 and minus 2.4 would be minus 2.45. And what is that? Minus 2.45.
Oh, I see. That would be minus 2.425. No, that's not it. That's not it. I do apologise. It would be 0.01444844375.
Beautiful. Okay, so we know that this is to two different places here, and that's quite accurate. So we can sort of safely say that x is going to be round about minus 2.45. And that's a bit further away from this answer here, so they're different, and you're going to get the same answer, but it's fairly accurate still. Okay. This is the final method here. I'd say the most accurate. It's called Newton-Raphson method, named after Newton and Raphson, because Newton sort of invented it and then Raphson refined it. So you'll be given the equation again, but this time you won't be given two numbers. You'll be given a number that's close to x, so it's near x. And so we don't know which direction it is. We know that it's probably above, because from our last answer it was above 2.4, minus 2.4. When I say above, I mean negative. So what are we going to do? We have to write that out of the formula here. So formula is x of n minus f of x of n over the differentiated version of that f dash x of n. And so differentiation in the last video would be dy dx, or dy dx this, and 3 comes down, 3x squared minus 3 is the differentiated version of that. And we'll substitute in minus 2.4 into that, so that's 3 minus 2.4 squared minus 3. And what's f dash x in that? 14 point something?
That would be 14.28.
14.28.
Of course.
And we know what f of x is because in the last time we did that, and we got, I think, 0.376.
That is true.
And so we know x of n is minus 2.4 minus 0.376 over 14.28. And what's our answer for that, Dilraj?
That would be minus 2.4263305332.
Usually this will work to a good 4 decimal place of the answer if you do it twice. And so what's the actual answer for all these? So
that will be minus 2.42598375.
Okay.
Thank you.
And so you can see that this number is actually pretty much exactly the same as the real answer to the equation. So Newton-Raphson is the best method, I'd say, for numerical methods. and that's the answer.